Good morning, friends. Welcome back to Karating. Now, this morning, I just want to briefly show you one of the nasty surprises that I came back to, having been gone for a little while in Long Beach. And this is just part of keeping it 100%. Unfortunately, this is one of the most painful lessons I've come to learn about trying to go cheap on some things. 4 years ago, we made a decision to go cheap, and now it's really coming back to bite us properly because the cost of fixing what you're about to see is not fun. So I want you to take a look at that roof up right there. What you're looking at is black mold. And for those of you who already know what that is, black mold is not a joke. It's not something you want anywhere around your home or around people that you care about. And in seeing that, you'd simply think, oh, that's just a roofing problem. Absolutely not. What you're looking at right now had nothing to do with the roofing job that was done. This was all about the solar folks, the cheap folks that we hired 4 years ago when we knew very little about how these things work. So I was actually just testing to see whether the gypsum board is still holding up before it falls on somebody, but it's still holding up. But yes, we went cheap and then we used amateurs, and these guys have caused us a mess. So right now, not only do we have an electrical problem, we have a solar issue, we have a gypsum issue, we have a mold issue to deal with, we have water issues here because actually the floor down there is wet. So one simple decision to go cheap on solar is now costing us a huge mess where I'm now having to hire different professionals to fix a chain of issues that started with just the solar guys. And so, yeah, this had nothing to do with my roofing guys. My roofing guys were just fine. We have very large concrete girders, but this had everything to do with the solar guys. So my guys came in. Yes, they were okay, but when you go cheap, there's always a price to pay for it. So on site today, I just brought in my folks who are cleaning up the mess. They started with where we have the inverter and the roof and the batteries to fix up all that, replace the wires. They're going to do quite a bit. So in the next segment of the video, I'm just going to let my folks explain what they're doing, and I'll also show you what my system kind of looked like before they made adjustments. And it's not exactly the same system. I'm showing you what my brothers look like, but the folks that I worked with were true amateurs. And of course, we were new to construction, so we didn't really know what we were doing. So if you can look at this system here, you've got wires hanging all over the place. And a lot of these are like 1.5, which are very small wires for the amount of load that was designed for our home. So this is where I had my folks start with by cleaning up all this mess. And you'll see what the new one looks like. And I hope you're not going to be like me. So join me, learn, and do better. So listen to them, and I will see you at the end of the video. Thank you, folks. Hebu explain.
Okay.
Yeah.
So, tukianza na hapa
Yeah, unaweza sema in English?
in English.
Yes.
But explanation vizuri acha tuachie hii.
Okay.
Hii mtu.
Hebu ingia hapo na English so that nielewe what's going on here.
Niseme kizungu kidogo.
Yeah. Toa ile kisumbu ya high school.
Yeah, high school.
Yeah. Hiyo iko tu sawa. Yeah. Hebu explain.
Thank you. So starting here, we have a DC breaker that serves the batteries.
Yeah.
So it helps in isolating the batteries. That is when you want to do any work on the inverter.
Yeah.
And also when there is any fault with the batteries, this breaker here will trip, and so it will not interfere with the inverter.
Okay.
Yeah, and then also here we introduced a consumer unit with a couple of breakers.
Yeah.
The first one is a DC breaker that serves the solar. So the solar panels, the wires from the solar panels pass through the DC breaker before it enters the inverter.
Okay.
So that one is important because sometimes there are things like lightning on the rooftop, and so the current, there is current surge.
There's a surge, yeah.
So when the surge takes place, to protect the inverter, we use a DC breaker.
Okay. Okay.
And also important just for matters of isolation.
Okay.
Yeah,
now how about lightning arrestor?
Yeah, so lightning arrestor is also necessary and not yet installed, but it should be installed.
Okay, what purpose would it be serving?
So the lightning arrestor will also help in diverging the excess current that is due to lightning from the solar panels to the ground instead of them coming
to the
Yes.
Okay.
And then we have two breakers here.
Yeah.
These are now AC breakers.
Yeah.
The first breaker feeds the inverter, that is the power coming from the mains.
Yeah.
That is this breaker here.
Yeah.
The power coming from the main line, the utility, passes through here before it enters the inverter.
Yeah.
And then the output of the inverter also passes through this breaker before it goes to the consumer unit, that is to the house.
Yeah.
Or you have the changeover, rather, it's called the system we have there, the changeover
Changeover,
switch.
yeah.
So this one feeds the changeover switch. So
Okay.
on the other hand, on the other side, we have the changeover switch for KPLC and the solar.
Okay.
So that is the system here. Everything is neat, nicely done. The wires,
The wires are not
here
hanging all over the place.
are
Yeah.
not hanging all over the place.
Yeah.
Also, they are of the right sizes.
Yeah.
That is able to sustain the load that,
Okay.
that is in this house.
So, because previously one of the issues I had is that I would be running out of solar power really fast. Was that related to all the stuff that was going on here, or that's a different story?
Yeah, partly related to the stuff that was going on here, because number one, the wires that we found here were very small wires.
Yeah.
That is wires of around 1.5
Yeah.
millimeters squared, meant to carry the load.
Yeah.
When such a thing happens, there is a heating in those wires.
Yes.
And so that is part of the losses, system losses that we always try to minimize, by increasing the size of the wires to the required standard. But again, about power that is running out of solar power, I can also say that because of the area where the home is situated here, the sun hours are always a bit like
Limited,
limited.
Sometimes,
It's limited.
Okay.
Normally we do 6 hours, that is for normal design, ideal design. But according to the nature of the area, I realized that it's about 4 hours, 3.5, because the rain starts coming.
During rainy season, rainy season,
So the solution there is we can increase the number of solar panels, increase the surface area, that is the wattage on the rooftop, so that more solar energy is trapped, and to charge the batteries to full capacity.
Okay.
So that is one. Two, we can do a load assessment for the entire building and see are the batteries enough. If they're not enough to store enough power for the house, then there also we can propose additional batteries.
Okay.
Oh yes, because the inverter has been serving. We can't say that it is small because it has not given any warning of overload. But we can see if it can sustain future loads. If it is small, then we can also increase that one.
Okay.
Oh, yes.
And what is your assessment of this particular inverter? Is it something quality, or you prefer something?
Thank you. So this is a must inverter, 5 kVA. So it is a high frequency inverter. So high frequency inverters are meant for light loads. It cannot contain large loads, especially loads like motors and even large fridges and large incubators and things like that.
So like for the ones like we use in the house here, is this inappropriate, or?
So currently it is appropriate due to the load size because it has not given any warning. But it will be better if it is changed to a low frequency inverter.
Low frequency inverter.
Oh yes.
Okay.
So that is always much better and more efficient than the high frequency inverter that is here.
Okay.
But in terms of capacity, still it is sustaining the load. No warnings given, and therefore we assume and we take that it is just okay.
Okay. Okay. So I think we.
When KPLC is out, this one will turn off. That is when there is no power in the grid.
Oh,
So
okay.
just at a glance, you'll know that
Oh, okay, I see.
KPLC is out.
Okay.
So that's its function. And then, of course, also the solar part. In case the batteries drain and the inverter shuts down, this one also will go.
Goes.
So this one does not indicate that both of them are supplying the house. No. To show that one, we use the manual one here.
Okay.
So right now it is on solar, so it is the solar that is running the house.
Okay.
In case you want to turn it off, put it at the center.
Okay.
Then for KPLC, we'll put it on the number 2 on.
Okay. And are they changeovers that are automatic, that as soon as power goes off, it just switches? So I don't have to come here manually and do that?
Sure. So this one is a manual one. You have to come and do it physically. But we have automatic changeover switches that does that function. Once power KPLC, the grid goes off, or maybe the solar, the batteries are drained, it will turn automatically to the ready level.
Okay. And this is your company, I guess, right?
Yeah, this is our company, Zurich Electrical Contractors Limited.
Yeah.
Based here in Kisumu.
Okay.
But have several other branches across the nation.
Okay.
We deal in electrical installations, maintenance also and repairs,
Yeah.
as well as solar, design, installation, and also repair services.
Okay.
Yeah. Additionally to that, we also provide sub-meters.
Yeah.
That is for any person that want to subdivide his power, rather to monitor the amount of energy that they're consuming.
Right.
So those meters are also compatible with the KPLC meters. So you can use them as prepaid meters in place of KPLC prepaid meters to pay directly and get tokens, load on those meters, and they just function.
Okay. Okay. And do you guys do lithium-ion batteries as well?
Yeah, sure. So that is part of solar installation of solar services.
Yeah.
So what we have just seen the other side, the normal batteries.
Yeah.
That is the gel.
The gel batteries, right?
Gel
Yeah.
batteries.
Yeah.
So in addition to that, technology has now gotten advanced.
Yeah.
So we have the lithium-ion batteries that are more efficient and also have more life cycles than the normal gel batteries.
Right.
And also they have greater depth of discharge than the normal gel battery. That means that they're long lasting.
Yeah.
And also that they don't get spoiled
Easily, yeah. Okay.
and also they occupy somehow less space because just one battery is able to store a lot of power compared to the normal gel batteries.
Okay.
You must have a big power bank.
Okay.
So yes.
Because I've seen single units where it's like one unit with like two batteries and it's all compact. You have those as well?
Yeah, so those ones also we have. Yeah, so that is the one of the biggest advantages of the lithium-ion batteries, because now the surface area of the area that they cover is really small, so they're compact like that and they store a lot of energy at once.
Okay.
So they're always rated according to design. Once we assess the load requirements of a house or a home, then we do our design and propose the appropriate one.
Okay. 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 All right. So yeah. So once